Hello and welcome to the second screencast on basic function plotting. In the first screencast we saw how to make a basic plot of a single variable math function. In this screencast we're going to learn about the Plot Tools window, a user-friendly and full-featured environment for manipulating the look and feel of a plot. We'll also see how to create a grid that displays several plots all at the same time. So let's begin in MATLAB by making a basic plot of a function. Let's define x equal to linspace -4 to 4. This will create a vector of x values starting at -4, ending at +4, and 100 values in between. Hit a semicolon to suppress the output. And the function I'd like to plot is y equals x cubed minus 4 times x squared plus x plus 6. And again, semicolon to suppress the output, and there we go. Remember, again, when we are exponentiating a vector, which is what x is, I'm going to have to use element-wise operations, so I need dot caret rather than just a caret. And also remember to put the asterisk in between any two things that you multiply. So let's get the plot here by typing plot xy. So we have a basic plot of a cubic. This graph is okay, but maybe we'd like to change its look a little bit. Now, in the upper right corner of the plot window, you see something that looks like a little window in itself. We're going to click on this, and this brings up what's called the Plot Tools window. It takes a little bit of time when it first opens up. And here we are. This is an environment where we can do things like add labels to the axes, change the color and thickness of the graph, and so on. So let's look at the major of the components of the Plot Tools window one at a time. First of all, click inside the plot area itself to get some options for your plot. We can name the figure, we can choose colors for a figure. If I click inside the white area here, I see places where I can label the x-axis and set limits on the x-axis. So for example, let's put just the word input there on the x-axis, and see when I type it in the text box, it shows up down here underneath the x-axis. And let's change the x limits here. I know that I have x defined to go from -4 to 4, but perhaps I don't want my graph to take up all that much space. Let's have x go from -1 to 4, for example. So I'm going to change this -4 to a -1. When I click out, it changes the look of the graph, and this is a much better looking graph. I can also change the scale on the x-axis. I can do the same thing for the y-axis, so let's type in a label of output, and you see it show up on the y-axis over here, arranged vertically, and we can change where the y starts and stops as well. Let's have y go from -4 to 10, for example, and there we have it. I can also change the tick marks here. Currently, you don't see an x-y axis on here. Here would be where the x-axis is, and here's where the y-axis is. So what I can, and you see the x's are split up by 0.5 units each, and the y's are split up by 2 units each. Suppose I wanted to change that, I would click on this button that says ticks, and it brings up another window where I can set the tick marks for the x-axis or the y-axis. For example, let's change the x-axis tick marks so they're every 1 unit instead of every half unit. Click on the x-axis, and I can do this one of two ways. I can either enter in the tick labels manually, or if I know that I want to step by 1 unit each, perhaps step by would be a good choice. Click that radio button, just enter in the step size that I want, so 1 instead of a half. Now click apply, and you see the tick marks change here and on the x-axis. I can do the same thing on the y-axis. Let's suppose I want to have more definition on the y-axis, so every 1 unit instead of every 2 units. Again, I would put step by 1, click apply. Or perhaps I want it to go every 5 units. I would just change that to 5 and click apply. I can put whatever steps I want. I'll keep it at 1. Now another thing I can do here is add a title to my graph right here in the title box. And so this will just put a nice header on top. I mean, maybe I'll put my nice plot here. I could even put in some math into this, y equals x cubed. Notice this is not MATLAB syntax, this is more like LaTeX syntax, where I'm just typing in the carets and so on. And you see it will actually format the math for me in a nice pretty print format. So there's the formula up on top. I can also add a grid. We don't get axes by default, but I can put a grid on here. By clicking the X, I can put a grid where I see little dotted lines going at every X unit, and same for the Y. So now that we've changed the region in which the graph is plotted, let's go click on the graph itself, the little blue line that we see here, and that'll bring up another set of options here. For example, I can choose plot type. This is not something we change very often, but it's helpful to see what's in the menu. This little drop-down menu lets me plot bars if I want to, like so. area, which is helpful if, for example, in second semester calculus you're thinking about the area under a curve. You can visualize it this way. Stairs and all kinds of different sorts of plots. We usually stick with line plots though. Now this has changed my values quite a bit, so what I'm going to do is click on the plot area down here and go back and change my x-axis to go from -1 to 4 again. There, now I'm back to the original. Click on that graph again, and I can change the line type. I can change it from a solid line to a dashed line, like so. You see that happen here. Very helpful if you have, for example, more than one graph on the same set of axes. I can also change the thickness of the graph. This is what this pull-down menu is for. Right now it's set at 0.5. Just for sake of argument, if I change it to 4, you see how much thicker it gets. Let's leave it there at 4. And I can change the color as well. I can change that to red, for example, or a nice purple, and that's how I can change the color. Now the marker, remember you see these little black squares that are plotted here. Remember, MATLAB only plots points, not actual functions. So if I change the marker from none to, say, a solid circle, I'm going to see, well, not much because I have this so thick. But if I change this back to 0.5, now you really see it. This puts a circle at every point that I plotted in the x vector. And that can be helpful sometimes as well. Let's change this back to 4 or 3 and change this back to no markers visible. If you want to see the data markers, you can change their look, their size, and actually their color as well. Now that we've messed with the graph quite a bit, let's see what else we can do with it. Over here in the left sidebar, we see a panel for annotations. Now I can add different little decorations and additions to my graph here. For example, an arrow. If I wanted to point, say, for example, to this little local minimum right here, I can click on arrow, and once this loads up, see it turns into a crosshairs. I can click and drag an arrow to point to different things on the graph. For example, say I need to go back and click on arrow if I want it again. Say there's an inflection point. If I wanted to have a text arrow, that would be an arrow with a little text box around it. For example, that inflection point. I click on text arrow and then drag the arrow to it, and when I get done, a little text box opens up. It's kind of hard to see, but you can just begin typing in, say, inflection point. And then when you're done, click out, and it leaves it there. And also add plain text boxes, just to add a text annotation somewhere in it, rectangles and ellipses as well. Now let's suppose I want to plot not only this cubic function, but also its first derivative and second derivative, not all in the same set of axes or in different windows, but separately in the same window. I can do that by going over here to the new subplots area in the sidebar, and clicking on this little square grid. What this is going to allow me to do is create a tiling of plots according to these various shapes that I can highlight. This one, for example, would give a little 1x3 row of 3 different plot windows. And let's suppose I want to put the first derivative here and the second derivative here. Well, my original graph is here. If I click on the second window, you see the frame show up around it. Now the next thing I plot is going to go in that window. So I'm going over here. I've already typed out x and its first derivative of y and the second derivative of y by hand. Let me execute those. And now if I type plot x, y2, which is the first derivative, notice in the figure window that shows up in the window. And let's put the second derivative here. Click on the window and see the frame show up. And I'll plot x, comma y3. And then that shows up over here. Now I can do any changes I wish in the plot tools window to this plot as well, like I did to my original plot. For example, changing the thickness, changing the color, adding a grid, and so on. The last thing we might want to do with a plot is to save it in a nice graphics format so we can use it elsewhere. I can do that by having my figure window up, and in the plot tools window go to File and then Save As. I've already got this set up to save as 3plots.pdf. I can save this plot as a PDF file or an encapsulated PostScript, a JPEG, a MATLAB figure, or a number of different graphics file formats. If I click Save, it will say yes, replace please. It will save that as a PDF. And now if I go look in my file finder and go to Documents MATLAB, which is where things are stored around my computer, there's the file, and you see it come up, and it's a very nicely formatted PDF that I can then incorporate in other places. So that's the Plot Tools window. We can use the Plot Tools window to change the look of our plot, add titles and annotations, and even save to graphics file formats. Thanks for watching.